29. All right.
So when it comes to the trimmed mean, the name says it all. You're going to have to trim off some values. And why are we going to do that? It's to basically get rid of bias or outliers that may skew your mean. Okay? Trimmed mean. This one is different than the arithmetic mean. Remember the very first one we started with? It's the arithmetic mean. It includes all values. Trimmed, obviously, will trim some values. That's the main difference. So previously we calculated the mean, median, mode, and sometimes they were quite different. These calculations, right, sometimes calculations can be skewed or distorted by the distribution of the data. Okay. If there's a number that is quite different from the other numbers in the list, the number is called an outlier. An outlier is a data point that is significantly different than the general trend. And here's the problem. I'm going to use a different color. An outlier can have a considerable effect on the arithmetic mean. Okay. To account for this, right, to account for the trimmed mean may be more representative of the measure of central tendency. Let me just try to focus one more time. When there are outliers, the trimmed mean, I'm going to use even a different color on this one. This is the definition. Trimmed mean is found by omitting an equal number of values on the upper and lower ends. That is basically what trimmed mean is all about. And I just got an idea here. Let's go back to the trimmed mean at the very top. And its main purpose is to remove bias. Okay, that's the main idea why you would want to do a trimmed mean, because it removes the bias due to outliers. And if you were listening towards the end of yesterday, I kind of alluded to this already. Oh, you want to box this in one? This is, again, trimmed mean right here. Short and sweet, a definition of it again. Calculated by disregarding, right, omitting an equal number of data points on both ends. You got to make sure you take off from both ends, or else it's not trimmed mean. Okay. So here's a panel of judges. I talked about this briefly, right? Let's say this is a bunch of high schools come together and there's a competition of some sort, right? And you're supposed to score, and there's different teachers from different schools. And let's say Sisler athlete comes up, and a judge that teaches at Sisler may be saying, hey, right, maybe not knowingly, but there's a bias, right? Oh, that's a 10 out of 10, right? But then you have Daniel Mack or Tech Walk saying, no, that sucked, right? The performance wasn't good. So you have another judge bringing it down. So these are skewing your actual score. So what we would do is we would say, well, let's omit the lowest, right? We omit the lowest and the highest is removed. And then we're just left with the three scores here. And so we would just find the average of the three scores that remain, and that would be more accurate, okay? That would eliminate any bias that is in the set, okay? Can you get rid of the 10% here? I didn't mean for that to make it, it was just supposed to say trimmed mean. And I have a lot of definitions here. They're always saying the same thing. Trimmed mean is the central tendency measure that cuts down the smallest and the highest values before applying the standard averaging, okay, for greater accuracy. And so here's the idea, right? This is the lowest, again, and the highest is omitted, right? So we trim that, we get rid of it, and so we're left with, instead of, we used to have 2, 4, 6, 8, 10 at the beginning, and we're left with 8 values. 8 values remain. That's important, okay, that you make note of that. Okay, so what's the purpose of trimming? To remove bias. Why do we trim? Because there's an outlier, or there may be several outliers. Okay? And sometimes the outliers are due to just an error, something went wrong that day when you do production or something. Right? I can think of the one, I used to work at Kitchen Craft. I've worked there for many years. And one day, one of the transformers outside exploded, and the whole plant was without power for over a day. So no production for a day and a half. You wouldn't count that into your normal average when you want to like say how much are we producing per day. You wouldn't include that in your calculations because that's like a one-off, right? An anomaly. So you account for that. So let's go to 30 here. Sometimes, okay, we're going to do the calculation, but sometimes trimming, right, will have an effect on the mean, the median, and the mode, okay? Or we're going to explore that. We're going to explore how trimming may affect the mean, median, mode. The mean, okay, you just have to listen to this part. The mean is almost always affected by trimming, almost always. Especially if there's an outlier, guaranteed that the mean will change. The median never changes. Okay, you're going to observe that in a bit. And the mode may or may not change. The only time the mode would change is if when you trim, right? Let's say your mode is at the end, on one of the upper or the lower ends, and you trim that away, it may change the mode in your set. You just have to do by observation. Okay? So let's determine the mean and the median of this set below here. And can I just add in your notes, right now, because we're including all of them, this is called the arithmetic mean at this point, if you include all values. All values included. Okay, so let's quickly figure out, is this arranged already? Yes, you're welcome, right? So we're going to find the arithmetic mean and the median. And because I already know you know how to do it, I'll just you just copy this down, okay? So if you add everything up, you get 41.7 divided by 10. That's going to be 4.17 units. We don't know what this what the numbers represent in this case. We just have a bunch of values, so that's what we get. What's our median? Can we just pick one? It's even, correct? So you're going to have to add 2 values and divide it by 2. I think that's fairly simple, that we can just figure out that it's going to be between these two here. 4 below, 4 above. So it's these two that we're going to consider. Just copy this down for now. You add those up and divide it by 2. I'm just going to give you the answer, 2.7 units. Okay, nothing new there. We've done this before. Determine the mean and the median of the set below after, watch this, after trimming the data as shown. So can you please do this? Like, just make sure you X this out, X this out. So we're trimming here. However, if I asked you which one is the outlier, which one of these two numbers where my fingers are pointing, which one of these two would be an outlier? This one, right? So if I ever ask you which one is the outlier, this is still the outlier. Okay? This is it's very different than all the other numbers. Like, there's a big gap there, especially look at the ends to figure out the outliers. This is not an outlier. But when you trim, you have to take off the same number on either end automatically. So let's say you forget, it's like, oh, how do you do trim? honestly, if you just take off the highest and the lowest, you're going to be safe. It's not always going to be a range though, okay? So this is the highest value, and this is the lowest. Okay, so we're moving on either end. So now we can call this not just the mean, it's called the trimmed mean, because we're not including all values. So watch how I'm going to do this. Watch carefully, because this is going to save you time later on. You have the choice to just add up everything that remains, but I'm going to say, I know that everything adds up to 41.7, correct? So I'm going to go 41.7 minus the 0.7 there, right, that lowest value, minus the highest value, 20.2. And then I'm going to divide by how many? Not 10, but 8, right? 8 values remain. So 8. Before I answer, what do you think is going to happen to the mean? It's going to decrease? Yes, right? Because you're getting rid of the highest, like the outliers, like on the upper side. So we're going to expect this number to drop. So let's go ahead and figure that out. That would give you 20.8 divided by 8. And so now you have 2.6 units. Bled a little bit into the other one. But watch this, it dropped, right? And then the median. What's my median here? It is the same thing. Because obviously, you now are not considering the outside, but it's still these two, because you got 3 below, 3 above. So it's still the same. Median is 2.3 plus 3.1 divided by 2. It's still 2.7 units. No change. No change there. And last but not least, we're going to trim by removing the upper 2 and the lower 2. Okay? So I will. The question is going to tell you trim the upper 2 and lower 2. For the longest time, I was not sure what the province is going to do here. Are they going to tell you? Are they not going to tell you? So last time when I went for training, I asked them, can you tell us, like, are you always going to tell students how many values to trim? And they basically said yes. They're going to say trim 1 on either end or trim 2 on either end. They're going to tell you that. But anyways, we're just going to go ahead and say these 2 are gone, these 2 are gone. I will emphasize this again. The lowest 2 and the upper 2. And you might be like, yeah, obviously. This is arranged, right? So it's easy to do here. But when you have it scattered, you have to look carefully for the lowest 2 values and the highest 2. So in this case, 6 remain. So to find the mean here, by the way, this is trimmed, so let's write this down here. As soon as you remove, we call it a trimmed mean. And obviously you're just left with 6. And I'm just going to say 20.8 minus the 0.9 here, minus the 4.4. If you subtract that, you get 15.5 divided by 6, which amounts to 2.58. Is there a big change from before? Tiny change. And the reason why there isn't that big of a change, just make sure you get this part, is because you've already got rid of the outlier after trimming 1 on each end. So if you then trim more, it's not going to make a significant impact anymore because you've already eliminated the bias. Okay? So that's what I want you to understand here. What's the median? It's not going to change. It's still these 2. Because you're trimming on both ends, the middle stays the same. Okay, so this will be 2.3 plus 3.1 divided by 2. And that is 2.7 still. So at the bottom here, mean is most affected due to outlier. Outlier or outliers. Median does not change. It remains the same. Okay, it's always going to be the same. Can you just, I just want you to go back up a little bit here and just make sure you understand that we did identify an outlier here. This set did have an outlier which skews or there's an unfair bias sometimes towards that. Okay, it would change your average. And I always like to I don't know if you're into sports or some kind of star whatever, right? If we have a Hollywood star come in here and it's like, hey, we'll find the average income for this classroom, that income would significantly affect our average, right? It would look like we're all making hundreds of thousands average, but it's not true, right? So you would want to remove the income. You would not want to include that. Okay. All right. So let's go and do a couple of examples. Maybe one will do. So let's go to 32 here. And you got to know that the province sometimes gives you tables with numbers. Sometimes they just list them like that. Just be comfortable with whatever they throw at you. Come on. There you go. All right, so there's a data set there. We don't know what units, so we'll just tack on units to our numbers. Calculate the arithmetic mean. This is the regular mean, right? Include, basically what that is saying, include all values. That's what that one is saying. So let's go ahead and do that. We can call this AM if you want, arithmetic mean. And we know that there's 1, 2, 3, 4, 5, 6, 7 values. And if we add that up, because I know you know how to do it at this point, it's 55, right, divided by 7, which gives you 7.86 average in units. I would like you to find the median and the mode as well down the road, so I'm just going to do that here, median and mode. It's very good practice to keep that in mind. For median, I need to arrange it, okay? So let's go ahead and do that real quick. Up here, wherever, I'm going to do this up here, and I'm just going to tell you that it's 3, right? And then 4, and then 5, right? 6, 9, no, sorry, 8, then 9, then 20. 1, 2, 3, 4, 5, 6, 7. I have them all there. Okay. Because it's odd, right? I can just go pick a number, and it's going to be 6, because 3 are below, 3 are above. So 6 units. Is there a mode here? No mode. Or NA. You can go NA, not applicable, or no mode. Okay. Now, we're going to identify an outlier and then calculate the trimmed mean. So, is there an outlier? It's 20. Okay. So, now we're going to figure out the trimmed mean. And I'm going to use a red pen for this one. For the trimmed mean, remember, the default is remove the highest and the lowest. Remove the highest and the lowest. So I'm going to go. Okay. So you have choice. You want to add what's left. One thing for sure is that I'm left with 5 values, correct? And this is up to you how you want to do it. I like to do it this way, 55, because I've already added everything up. And then I just subtract the 3, and I subtract the 20. And I'm left with 32 over 5. Can I fit that in there? It's going to be tight. I'm just going to do it here. Trimmed mean is 6.4 units. I expected that. I expected the drop because there's a high outlier. I'm just going to say next to here is high outlier. Sometimes there's a low outlier on the low end. Sometimes there's a high outlier on the higher end. So removing, if you remove a high outlier, you expect it to drop. Okay? I'll write this down. I expected it to drop since a high outlier was removed. Okay? You removed 2 values, but one of them was that high outlier. And so you expected it to drop. What do you think the median is going to be? It's still 6. Right? If you pick 6, there's 2 below, 2 above. So it's still 6 units. No change. The mode is still NA. Right? Not applicable. Nah. Right? Is there a mode? Nah. I wanted to make a joke about sodium, but I was like, nah. That's a chemistry joke, by the way. Explain the difference between the arithmetic mean and the trimmed mean. I'm going to give you the shortest possible version of this. Arithmetic mean includes all values, even outliers. Okay? It may be skewed for that reason. Not always, but it may be skewed because of that. Sorry, what did I do here? The other arrow was supposed to come out of trimmed mean. Trimmed mean found by removing the lowest and highest values. It omits outliers and is therefore more representative. Here's the central tendency. It's a more representative measure of the middle, if you want to put in your own words there. Okay, I'm going to stop here and just ask you to practice. Go to page 33 to 36. Practice trimmed mean questions. If you think you already know it all, at least try a few to see if you really know it all. Right? Before you've tried it, you can't know for sure. Okay. And there might be scenarios that you come across that I may not have covered in as much detail, but it gets you thinking. And so if I go over it tomorrow, you'll have a pretty good idea. Pause it here.